Okay, so yesterday I think we looked at the data types, right? Mainly the primitive types, and earlier we had looked at we got introduced to the data types. We saw about the char type, the Unicode, about the Unicode character set, right? And so, any questions so far for whatever we have covered? Yesterday, what I have done in this text file itself, notes, right? I have pasted the session for JShell, whatever we did in JShell, that I have pasted here, right? So,
Okay, sir.
yeah. And yeah. So, any question? Yeah. Anyone has questions so far?
No, sir.
Okay. Fine. So then let's start. So yesterday, I think the last thing I had given was a small exercise. Okay. And one small example of array where we were using a two-dimensional array. Okay. Then I'll pick up that code and put it here again. Yeah. Okay. This was that code. Fine. So the question was, what would be the output? And why? Because one can always run this and test out. Yeah. So yeah. So what's the output? What should this be? What's the output which you feel should be here? We are setting a of ij equal to I plus j, right? But before that, yeah, we have done something here. Okay. And this code says, okay, just allocate a two-dimensional array, right? Which has 10 rows and each row has 5 columns, right? And okay, so what's the effect of this one? First thing, yeah, what is the, fine. So what should be the output here? What do you think will be printed? Yeah, see, to know the answer, two things are important, right, in this. One is this and the other is this. So I plus A03.
Output might be 5.
Okay, right, so this is going to be 5. So that's correct.
5, yeah. Yeah.
So why does it happen this way?
Actually, Nicole, there is some background noise at your end. Yes, okay, sir. Thank you, Nick. Yes, sir, go ahead. Yeah, Rasmika tried to say something.
No, Rashmi nahi hai, Rashmi hai. Thank
Sure,
you. I
sure.
think I was just saying I can't hear because of some background. It's muted.
Okay.
Okay, fine. Yeah, so how this is 5? Yeah, I think the answer is correct. It is going to be 5. Yeah, but how does it happen this way?
Yes, sir. So like we have place 80 value 82 to second position value of A0's element. So
Yeah.
0, 1, 2, and 3. So that's why it's getting 2, and at the third element of that J, so 2 plus 3, that is 5 answer.
Okay. Okay. Fine. See, it's something like this. This statement A2 equals A0. If you are looking at everything as rows, right? The effect of this statement is, oh, so we got 10 rows here. Okay. The effect of this statement says, okay, the row at index position 2 is same as the row at index position 0. Okay. So whether we use from this point onwards, fine, from this point onwards, whether we are using A of, okay, 0 and anything, right? It could be some value j, fine, or, okay, so this and A of 2j are same. Okay, fine, it's going to be same. 0j or 2j, oh, that would be same. J could be any value from 0 to 4. Okay, fine. Now when this loop happens, it will initially see, loop is happening for j equal to 0, for I equal to 0 first. Okay, fine. So when I is equal to 0, your 03 A03 gets updated to 3. And initially it will get updated to 3, but when j becomes 2, sorry, when I becomes 2, right, it will update same thing, because it's A0j or A2j is the same, so it's the same position which is getting updated to value of 2 plus 3, 5. Okay, fine, I'll show it here again. Okay, let's see. Fine, so what exactly happens is like this. Fine, when we said new int 10 5, right, so what happened, we have a reference for A. Okay, so this is A, reference to an array which contains reference to 10 different rows. Okay, yeah, so here are the, okay, this is 0 1 and so on. There will be 2, so this is index 0, this is, sorry, this is 1 and this is 2, not 11, this is 1. Okay, fine, and so on, and this would be index position 9. Right? And each one, initially when it was allocated, each one was referring to an array with 5 elements. So the 5 integers were here. Okay, so this was also having something. Okay, so this one or this also has another array. Okay, so like this, right? So each one gets its own array. Okay, fine. So initially, we'll go through the loop. So we'll say I equals 0 and update here. So this becomes 0 1 2 3 and, oh sorry, it's not like this. Fine. Even before this, right, before this starts, so before we start updating, what is the first statement we did? A refers to this array, and then we are doing A of, what's the effect of A2 equals A0? It could have been even other way around, A0 equals A2 would not have made a difference. The effect of this A2 equals A0 is in saying, okay, A2 here, you stop referring to this guy, right, and start referring to the same place. Fine, clear? So it's like whether you say A0 of something or A2 of something, it's the same row. A0 and A2 are the same row, same array. Okay, fine. And then what happens is we go through the loop. In the loop, initially I was 0, it would update this and make 0 1 2 and 3. sorry, 0, 1, 2, 3, 4. Yeah. Okay. Fine. I would become 1. It would update 1, 2, 3, 4, 5. I would become 2. But when I becomes 2, it's updating the same row. Okay. So in this row, you'll get here 2, 3, 4, 5, and 6. That's what will happen. Okay. Fine. So clear. It's just overwriting the same row. 0 and 2 are the same row. Okay. Clear on this? Yeah. Fine. Okay. Fine. So then, fine. Clear, right?
Yes, sir.
Okay. And so then let's proceed. Yeah. So any questions? Any other questions anywhere? See, this is more to understand about the reference. Okay. The idea was that you get reference thing properly. Okay. Fine. Okay. So now, fine. So fine. So we understand two-dimensional arrays. Okay. Fine. Okay. So fine. Just like we have two-dimensional array. Okay. We can always have multi-dimensional array. Each dimension is one more level basically, right? This was having two levels, two dimension. First was a referring to a array. That array in turn has a reference to further arrays. So if we have a multi-dimension, so we can have always have a multi-dimensional array. Okay, the number of dimensions, the maximum number of dimensions. Fine. Is 255. So you can't go beyond 255 dimensions. Anyway, we normally don't go beyond 2. Okay, 3 is also rare. Fine. But for some mathematical model, someone might have requirement of going beyond 3-dimensional also. So here we have a restriction. You can't go beyond 255 dimensions. Okay, fine. So one thing we have seen, fine, we now understand about the reference type. A reference, right? So variable of a reference type is always a reference to some object, and object can be of that type only, right? Okay, fine. Okay. Okay, fine. So a reference type, fine. So when we look at the reference type, yeah, what were the reference types? So first was arrays, classes, interfaces, enums, and sorry, annotations and records. Okay, fine. Basically, among this we say these are categorized into two kinds rather. Okay, not two kinds. These 5 of them. Okay, fine. One is array. So they are a separate type. Array can be for any type. Fine. For example, this was what when we were looking at a two-dimensional array, it was an array of an array type. Okay, fine. So and so arrays for any type. Array is also a type. Okay, fine. And yeah, earlier we had defined in a single Java file, we defined all the 5 items, right? Class, interface, enum, annotation, and a record. Okay. Fine. So example of I think we have done an example of a class, but not as a something where we were creating object or anything. Fine. Okay. Fine. So we will be having more detailed discussion on classes, fine, interfaces, enum, annotation, records, and all of these will be discussed in more detail. Fine. Later. Okay. But just a quick idea, I can just okay here. Fine. When we say yeah, class means it's like just creating a data type, right? But the idea for class is that you would then be creating objects of that type. Okay, fine. So for class, yes, we can have objects. We can have objects for the enum types and the records. Okay, fine. So classes, interfaces, and records are, we call them as the class types. Okay, these are nothing but uh, and there are some or the other kind of a class. Okay, interfaces and annotations are the interface types. Okay, fine. So basically broad categories, we have class types and the data and the interface types. Okay, the normal idea here is that yes, we do not have objects of the interface type. Okay, we don't directly create object of a interface type. Okay. It's more from the point of view of inheritance that it is, these things are available, right? Interfaces. Okay, fine. There's one very basic difference between uh, classes and interfaces. Okay, I'll just try to put that basic difference here. See, when you define a new data type, when you define a class, okay, okay, we'll be looking at how to define a class later, what all things can go. Fine. Okay. So, when we define a class, fine, we can, okay, we specify, fine. The class definition basically is for specifying the structure for the objects of the class, fine, as well as, okay, fine. So it's not only about structure. We also mention, so when we say structure, I should put the word state. Okay, fine. Okay, so what is the state information which a particular object of which the object of this class can have, right? So it's not only about the state, but it is also about the behavior. Okay, fine. So behavior, that defines what is the kind of interaction, okay, one can have with the object. So if you have an object of this class, yes, this is what you can apply on the objects of a class, what operations can be performed, fine, that kind of information. Okay, fine. So this is with mostly what you give in a class definition is related to the objects of that class. So what will happen if I have an object of the class? Okay, fine. So the class types are on those lines. Okay, so the main important part is class has state information related to the objects as well as the behavior part, whereas, okay, interfaces, okay, okay, interfaces cannot have state in, cannot define, fine, cannot state, okay, yeah, uh, cannot declare anything related to the state of the object. And it can only talk about the behavior. So we have basically, this is the main difference. Interfaces are more about behavior for any object which is of this type. Okay, fine. And yeah, okay, so this is more like this, like, okay, so we have classes and interfaces, that's one thing. Okay, class types and interface types. And class types, yes, we will be talking about state. Okay, when we have class types, yes, it's more about the state and behavior both, fine. Whereas interface is only about behavior and not about the state of the objects. Okay, let me now again give some more classification, right, for the class types and the interface type. Fine. One is, yes, for the class types. Okay, for the class types, which is nothing but your classes. You may have classes, interface, not classes, enums, and records. Okay. For classes, enums, and records, yeah. Okay. Further classification. Now I'll go into the classification for the class types. Okay. So when we will go into the details, I'm just giving the categories. Okay. As far as classes are concerned, you may have classes which are also called exceptions. Okay. There's also another category. You may not be using this. I mean, you may not be defining these types. Okay. So we have exception. Okay. So fine. I'll use the plurals here. Okay. So we have exceptions which you can define. Okay. So exceptions are nothing but special kind of a classes. So there are special classes which will be exception classes. There are special classes which will be error classes. There are also within these classes, there are classes which will say, oh, this is a generic class. Okay. Okay. So we may have what we call as a generic classes. Fine. What is generic? Oh, that will come later. Fine. But I'm just giving broadly the categorization. Okay. Fine. So we can have exceptions, errors. Some of our classes may be generic classes. Okay. So we have a here we may have just a simple class. We may have a exception class, error class, or maybe it's not a simple class. It's a generic class. Okay. Fine. So this is categorization for classes. Now same way categorization for the interfaces. Okay. So if I look at an interface, yeah, when you define an interface, we have a few. There's one another within this. You can have interfaces which are again generic interfaces. Okay. Fine. Now the next thing which is related to the interface, okay, is like this. Some of the interfaces, so it's like across both. Fine. I think what I can do here is just to say interfaces. Okay, I can put it here also. We can say simple class. Okay, so it's not falling in the other categories. So you may have a simple class, you may have a generic class. You may have exceptions and we can have errors. So same way, let me put like this. We have interfaces which may be a simple interface or generic. So the categorization is between, okay, there are interfaces which are generic, there are interfaces which are simple, which are non-generic. Okay, now across both of these, okay, so across both of them, whether they are simple or generic, okay, you do have a categorization, okay, where we can say, oh, this interface is a functional interface. Okay, fine. So see, what is a function? If you look at a function, fine, used for creating. Now I'm putting this can be used for creating function objects. Fine. Okay, so you would be able to use, fine, fine. So with this, you should be able to create a functional object, function objects here. Okay. Yeah. See, function is more about behavior only, right? It's not related to a state, right? So when we say functional interface, yes, using function interface, fine, we can create a, we can say used for creating function objects in bracket. How this is achieved? It is achieved with the help of a lambda expression. Okay, so we create a function object by using a lambda expression. So this is some this feature, right, has been added. Generics is a feature added from Java 5. So both places, whether we talk here or here. Whereas this lambda expression, function interface, this is from Java 8 onwards. Okay. Fine. So fine. So within interface, yes. Okay. Yeah. Fine. Another category anyway within interfaces, which we know as other things, which so within class types, right? Classes are like this. Within interface type, interfaces are like this. Okay. Fine. So annotations, enums, and okay, I'll put like this, that as far as when we are talking about the class types, okay, uh, fine, records are closer to this class type. So you may have a record which is generic, okay, fine, you can have a simple record also, okay. They are a special case of a class record, okay. Even enums are a special case of a class. Let's see, enums. Fine. Enums are classes, fine, which have a fixed set of objects which are specified as part of the enum definition. So objects have to be specified as part of the definition itself. So you will always have those fixed objects, that's it. Okay. And when you define a class, you don't mention the objects normally, okay. But the enum is a type of a class where you need to mention the object list. Okay. So the fixed set of objects are part of the enum definition itself. Okay. And yeah. Annotations, I think we have used annotation, right? Annotations are used for uh, programmer defined modifiers. Annotations are nothing but programmer defined modifiers, right? We understand we can have modifiers for various kinds of elements in a in our Java file, right? So when we, I think I'll open that code for day one to relate all this. Okay, fine. The code which we had, let's check this code. This was it, hello.java, which we had done. see, this code here was only to show that all these 5 types are data type. 5 things are data types, right? So hello world is a class, so it's a data type. I can declare variables, and so this all code compiles with enum. And if I go downstairs, yeah, here it is. With enums, you can see enum is just like a class, but it has to have the list of objects as well. Okay, because the list of object is a part of the hello enum, right? Hello and hi, we have said, oh, we will have 2 objects like this for. So this is a special class, okay, which has the definition, right? So which has the list of objects. So here in our application, when we write a main method, we know this is our application, and so we have been able to use this. We have said, okay, oh, the hello enum dot hello. So I would like to assign an object. Okay, which object? This is my variable. It would refer to the one of those 2 objects, right? So it can refer to only one of those 2 objects, since we have only 2 objects of the type hello enum. Okay, so this is what we did. We printed that object, and then we had this one. Okay, we assigned the other one and we printed it again. Okay, and so this is something which was done. And so enum, fixed objects. Okay, another thing what we did was we said, okay, we will have our annotation, and we defined an annotation, gave the name as difficulty. Okay, added an attribute to specify that yes, I have an attribute, right? So for specifying an attribute, we add a method in an annotation. Okay, so annotations defined by using @interface, and here we said, okay, we will have a annotation. This annotation is difficulty, and this difficulty has a attribute which is of type int, right? So that's the type int, and name of the attribute is level. Okay, and then we have used it as a modifier. And for example, I think we initially used it with okay, we used it even with the class definition. Did we use? No. Okay, okay, we could have done here also, right? Because I've said, oh, this class is having a difficulty level and so and so. Yeah, interface, yeah, enum, record. Anywhere I could have used it as a modifier, right? Many times, oh, I want to have a record which is a public record. I could have said public, right? But similar to that, it's a modifier. Okay, so I can say, okay, this enum here, or maybe we'll do it for the interface, right? So this interface here, I can say @difficulty, okay, and I'll say level equals some integer value, or level is 1. Okay, fine. So this is just nothing but one more modifier. Okay, fine. We don't have any other modifier for the interface, but yeah, you could have done that, right? Okay, and then we did for so it could be applied to any element of our Java. Okay, so it can be applied even to a method. So this method has modifiers. Main has public and static, but oh, I also want to assign it. I want to annotate and say this is having a difficulty level of 1. Okay, see, to make a distinction that yes, this is a modifier, okay, which is a programmer defined, you'll have to say @. And so we use that separator called @, and then the name of the annotation which we would like to specify. Okay, and so this is the it's part of the list of modifiers. Okay, fine. We have even used it with a variable which is as a parameter, right? So this method has a parameter which is string array, right? Type string array a, that's a variable. Type is string array. But I want to say, oh, I want to annotate it. Yes, I can do an annotation. This is only to show where annotations may get applied, or they may even be applied to a declaration of a variable. Okay, fine. Yeah, so the purpose of annotation is simply we don't create objects here directly for the type which is an annotation. Okay, fine. We don't create such objects, right? But we use it in a different manner. We use it as a modifier. Here, and this modifier, how it will be used is a separate aspect altogether. Okay, right? How this someone will have to, someone wants to analyze the difficulty levels and other things about the code which has been developed so far. So if the programmers have followed this and they have put this annotation difficulty, right, with their levels in various part of the code, right, someone could write a separate application which can do the analysis on based on this. Okay, we are not going into how it is used here. Fine, how someone can find out what are the annotations, how to extract this information. But yes, it allows us that kind of a flexibility. Annotations are important mainly because this is what is being used by most of the frameworks. And you will find, oh, with Java there are so many associated frameworks. For example, you will have the most commonly used one and very popular one is the Spring framework, right? So we have Spring and then Spring Boot. Right? So Spring framework is there, but all these frameworks, they use annotations extensively. So what they have done is they have created their own set of annotations. Okay, annotations are programmer defined modifiers, and then they'll say, okay, this annotation should work for any kind of a class. So if you are declaring a class, okay, put this annotation to indicate something which is related to the configuration about some information, additional information which is not part of the Java language. Okay, fine. So to create that additional information, yes, we have the annotations serve that purpose. So frameworks very much uses, they have defined such annotation, and then they've said, okay, when you define a particular kind of a component for their framework, you please annotate it like this, so that I can identify this is a particular kind of a component. Okay, so that's the whole idea here, right? So frameworks use this extensively. Okay, so most of the time you may not ever be required to define your own annotations. Okay, fine, but you will be mainly the users of the annotations when you switch to programming using the frameworks, right? So all the frameworks, yes, they use this annotations a lot. Okay, so then it's mainly about, you learn the whole Java language, but then okay, when you want to go for uh, uh, using the frameworks, you need the frameworks. The additional thing will be, oh, what annotation I use for what purpose, right? So they have a lot of annotations. So you will normally be required to know those annotations which are available in a particular framework. Even Java language, the Java library contains some standard annotations, right? And we'll be seeing those standard annotations which are part of the Java library and how they are useful. There are some of them which are very commonly used, and there some of them are related to if you are overriding a method, fine, you may declare that, oh, I'm overriding this method. Okay, fine. We'll see as we go along. Okay. So the whole idea of these 5 types is there. Fine, we have those 5 types. Record type, yeah, we will be having example once we understand about the class definition. We'll see an example of a record also. Okay, fine. So one thing, what it clearly shows that Java is more about these 5 items, right? Okay, class, interface, enum, annotation, and record. Okay, fine. And fine. So what we need to do is we need to understand these types. They are all types. So Java is all about types. We have inheritance, and therefore we'll have something called supertype and subtypes. The relationship of supertype subtype. Okay. Fine. So all fine. So all those things will come. Okay. Fine. So now, so that's, I think, just an overview of the reference types. I just wanted to give a brief overview on the reference type. Okay. Okay. So let's get started with the next topic. So next we look into the operators. Yeah. So operators, fine. So in Java, we'll have operators similar to, we have operators uh, in C language. Fine. It's quite similar to what we find in C. Okay. Of course, there are differences. So mainly, I'll like to highlight where the things differ, or some if some places which I feel okay, it's not normally known, and I'll point out those things. Okay. So yeah, operators in Java, right? So very similar to, so first we have that list which is similar to the list in C language. Okay, what matches the C language? So in C language also we have various categories of operators. For example, we have the arithmetic operators. So which are the arithmetic operators? And I think we know this: plus,
Addition, subtraction,
division,
division, and
and modulus. Okay, fine. So these are the four arithmetic operators. Okay, so available in Java. Now, one important thing about Java, right? These operators would work for which types?
all numeric types.
Numeric types. Okay, fine. So it's not available for the Boolean or the reference types. Okay, fine. See, this is,
But in Java,
yeah.
okay. Sorry.
Yeah. Okay. Now, so in the numeric types, we know this hierarchy of the numeric types, right? Double is the highest, right? Below that is the float. Okay, I'm just repeating what we had done earlier. Okay, fine. Below the float is, so okay, I'll just indent to say, okay, it's a subtype, right? It's a subtype of float is a long. Under long, you'll have int. Under int, you'll have two types, right? There is the short and the, okay, I think I'll put the char first. Okay, and we have the short type also. Under short, we have the byte. Okay, fine. So subtyping is like this hierarchy. Int has two subtypes, and short has just one more subtype. Okay, fine. So we understand this, but one thing to know here is internally, Java uses only these four types. For arithmetic, only these four types are available. Okay, so if anything is a char, short, or a byte, okay, it will get converted into int and used like a int. Okay, I'll show with an example here. Okay, fine. Suppose I declare byte, okay, b1 equals 7. Okay, this is fine. And you might say, okay, byte b2 equals 8. Okay, now if I say I want byte b3 equals b1 plus b2, it would be a compilation error. Fine. This is, we have used plus, right? So this is b1 plus b2. What is the type of this? Okay, I should say, okay. What's the type for b1 plus b2 expression?
There is no type, even though both are Boolean plus not.
No, they are byte. They are not Boolean. They are byte. Sorry.
Oh, sorry, my. So what is the type? Int.
Yeah.
Not in a byte. I'm so confused.
So this byte, short, and char, they always get converted into a int. Okay. So when I'm doing a plus operation, right? Okay,
Hmm.
so fine, A plus B. Okay, fine. The type for A plus B will be the higher of the two types. Okay, so this is one statement. Okay, fine. It would be minimum. It should at least it would int type. It cannot be smaller than an int type. Okay, so this cannot be smaller than an int. That's one thing. Okay, fine. So if A and B, one is okay. So this we understand. So A plus B1 plus B2. Okay, the type is int. Right? And you can even do this, right? For example, you might even try this. Okay, A plus B. Oh, these are char types, right? And I can do addition with them. So if I do A plus B, what will be the result? The result is an int type. Okay, so let's say int x equal to A plus B. So what do you think is the result? Okay, what is A?
It is A is a character but represented as int.
The value is 97.
Okay.
Okay, 97 plus 98. Okay. So even if you write char values, right, it's not this plus is not a string concatenation. It's a the type is a char, which is a numeric type. Okay, char is a numeric type. Understand that. Okay, so this is equivalent of saying 97 plus 98. Okay,
195.
yeah, this will be 195.
But you can only represent one minus 127 plus 127, right?
So it's an int type, na?
Int.
It's not byte. It's an int type. The result is an int. Conversion to int is taking place first. Okay, fine. So anything would be converted to int first. Okay, if it is char, short, or a byte involved in an arithmetic, any arithmetic, it would first be converted to a int and then used like a int. Okay, fine. Now the type of A plus B will be the higher of the types for A and B. Okay, so let's check on that also. Yeah. Fine, we'll have to say int. Okay, B3 equals B1 plus B2. Fine, that's for the type. Because of the type, type becomes int. It won't be byte. Okay, now higher of the two means another thing. So if someone says I have got double A equals whatever the value may be, okay, and you got int B equals something, okay, fine. The A plus B will be of type, yeah, what's the type? Double. Okay, A plus will be of type double. B will first be converted to a double. It will be promoted to a double, and we have two doubles being added. So internally, fine, Java has only 4 add operations which are available. Okay. Rather than Java, I should say JVM. Okay. As far as addition is concerned, okay. Knows adding to double, okay, to it can add to double, it can add to floats. It would be the same type that it can do operation on. And so it's not required by you that you have to use the same type for add operation. The two types may be different. Then the smaller type gets converted to the bigger type, but the operation finally happens on same type. So if it is one is a double, other is a int, the int gets converted to a double, and then the two doubles are going to be added. Okay, so internally there is addition of two 64-bit floating point values, addition of two 32-bit floating point values, addition of two 64-bit integral value, right? That is the type long, or addition of two 32-bit integer values, right? The type int. So it knows int, find two ints, two long, two double, and two float. And that's the only 4 addition operations which it knows. Okay, rest all is through conversion. Fine, it allows it because of the conversion which is there. Okay, fine, so get this point, I think. Yeah, okay, fine. So this is applicable to all the arithmetic operators. Okay, fine. About the types, conversion, type conversion, fine. We call this as a widening conversion. Okay, so we have a widening conversion which happens like this. Fine. Suppose I was interested in doing this itself. Okay, I was interested in getting it as a byte value. What would it be done? You would have done this in C language. I don't want to say this is invalid. I want to achieve this a plus b, whatever is the result, right? This result, I want it as a byte. What do we do?
Then casting.
Casting. Okay, so casting is a narrowing conversion. Right? Converting from a bigger type to a smaller type. Okay, the type of b1 plus b2 is int, but that's been converted to a smaller type. Okay, int converted to a byte, that's a narrowing conversion. So widening conversion, making it bigger or making it smaller. So narrowing conversion happens through casting.
Mr. Jain, in Python,
Yeah,
casting does not narrow anything.
no,
It
it's
can also.
no, it's not casting. Basically, it's not casting.
Oh.
There's nothing called casting in Python. Basically, what you are doing, actually, you don't look at it properly in Python. I'll just a short deviation to Python. Okay, okay, okay. So what you may have been doing is something like this. For you'll say, okay, I have got x equal to, and here you are saying, okay, 7.4, right? So the type we know is a floating point type, and now you're saying y equals, and you will say, oh, let me convert to a int x, right? This is what you do. This is not conversion. Basically, you are calling the constructor.
Oh. Of int, which will not.
Int is a class, basically. Fine. There,
this is a class. Int is a.
Everything is you have class. You don't have the primitive types. Okay.
Yeah. So Python doesn't have any data types. Even primitive data types are not there.
No primitive types. It has all things are classes.
Okay.
So it's always an object, no primitive value.
Thank you.
Okay.
सी में क्या होता था, प्रिमिटिव वैल्यूज थे ना?
हाँ, C was completely having primitive, and then we had the struct, type def, and union, those kind of
हाँ
things.
हाँ, ओके।
Okay, fine. So, clear. So we have conversion, right? Okay. Now, since we are looking at conversion, I'll show you one more type of conversion. Okay. Fine. There's just so we are deviating from the arithmetic operator. We are just looking at another type of a conversion. Okay. So we have another conversion which is between the primitive and the reference types. Wrapper type. Okay. Fine. So conversion between primitive types and their corresponding wrapper type. Okay. So it's in both directions. Okay. Fine. This conversion, now this kind of conversion which I'm talking about is available from Java 5 onwards. Okay. So prior to that, there was no such conversion which was available. Okay. But now from Java 5 onwards, the kind of conversion which we can always do, okay, at any point of time is it will look like a casting. So for example, if I have an int a equals 75, so this looks fine. This is of type int, right? It's a primitive. But someone says, I want an integer b equals, and I can cast into integer and say a. This is fine, but as such this would not even be needed. This conversion happens automatically, but this is also valid. When you're using some expression, you may like to indicate that I would like to use it as an integer type. Okay.
Mr. Jain, what is the difference between wrapper class integer and tiny IMP?
Okay. Okay. A is a value. Okay. A is a value. Fine. B is an object.
Got it.
Fine. Okay. So a
So on a
variable.
value, primitive arithmetic method, on an object you can do much more.
Yeah. Okay. It's like A has the value here, right? Whereas B here is reference to an object which contains the int value.
Okay.
And this is my wrapper object. This is A is of type int, and this is of type integer.
Got it.
Okay. Right. So conversion between. So this is for conversion, right? And same way, someone could say int c equals and cast as int b. This is also okay. This is right. Right. So the whole idea is this: b is an integer type, but I'm making it into a value type, from object to a value. Okay. So this you fine. It's not. We don't call this as casting. We call this as a. This is a because it is from an object. Fine. Object contains the value, right? So we'll say, oh, it is inside a box. Object is a box. We call object as a box basically for a primitive value. Object is a box which contains a primitive value. So the conversion which happened here, fine, we call it as a boxing conversion.
Boxing means widening, right?
Boxing means primitive into putting primitive into a box, uh, putting primitive inside an object.
Okay.
Okay, and
And
this
what
we
happens
call
in second point?
unboxing conversion. So you're pulling out the value into from a object and keeping it in a primitive type.
Primitive type.
Okay, fine. Okay, but one more point here is this will happen automatically. Okay, I'll put this code again. Okay, fine. Fine. So this will, we call it as auto boxing conversion. Okay.
Only Java has this.
Yeah, Java 5 onwards, it's like this. We have auto boxing conversion, and same way, this one here. Okay, someone is doing like this. Okay, I don't need this. I don't need this. Sorry. So this is your auto unboxing conversion. Automatically.
Is Java a strict typed language?
Java is a strictly typed language. Yes. Java is a. So what do we understand by strictly typed language?
Not Python, basically.
Yeah.
Meaning you have to declare the data types ahead of time. And you cannot keep changing them. In Python, I can say int a equal to 5, and then in the next statement say a equal to cat. And Python will just overwrite the old one. This is very weak typecast.
Yeah.
What is very weak data typing. You cannot do this in C, and the compiler will complain.
Okay. So fine. The strictly typed language would mean the type for every expression is known at compile time. There is a type which is there are two types basically. There is a type which is known at compile time, and there's a type which is known at runtime.
Okay.
We'll see this
In
also.
Python,
Yeah.
okay.
So in Python, there's only runtime. There's no compile.
There is no compiler. It's an interpreter.
Yeah. So
So
strictly.
I'm Python interpreted, but it can also be compiled, right? When
Yeah.
you big Python file, like not
It's not.
interpreted means one time.
It's not exactly compiling. It has to run it.
Oh,
Okay. When it is run for the first time, it does generate some kind of a code which someone can carry.
okay.
Okay.
So dot py never generates a dot class or a dot exe, nothing like that.
No.
In Python,
No.
it's
No.
just
But sometimes,
automatically.
yeah, there is some intermediate code which is generated anyway. It does generate.
But we can't,
But you.
unless there is an error, we can't. Okay.
And fine. Okay. And so compiler is able to decide the type for everything. So that has to be there. Okay. Fine. See here, what's the type for a? Int, right? Fine. I could have even said, if I say byte, x equals 75. The type for x is byte. The type for a is int. Okay. Fine. At runtime, what is the value? 75. It's a valid byte value. Okay. Fine. So runtime, there is one type. Okay. It will be more applicable to the actually the reference type anyway. So we'll talk about that runtime and compile time types later. Okay. What's the type of an expression at compile time? How the compiler, so what you declare is what is known to the compiler. Okay. So when we do a casting, we are changing the type. So we are saying, okay, your type is going to be int. Okay. This expression is the type is int here. Okay, so this is one expression when we put a cast operation. Here it's a unboxing conversion. Okay, right? But this code, we find that automatic conversion is taking place. So why do we still need that casting, right? It's not exactly a cast. We shouldn't call it as cast. Why do we need the explicit conversion operation being specified? This for boxing conversion may be needed at many places. Okay, fine. We'll come across that later, right? But yeah, keep this in mind that we have boxing unboxing conversion which is allowed. Okay, fine. Just like we do a casting. So this can be done only between the corresponding types. Okay, fine. This is for example here, fine. If this a was a byte, okay, you won't be able to convert it into integer. This would not be valid. You can convert into the corresponding wrapper only. Got the idea? Okay, it's fine. It's not like between the numeric types anyone can be converted to anything, right? It's not that way. As far as boxing conversion and unboxing conversion is concerned, it is between the primitive and its corresponding wrapper type only. If the type is int, it can't be taken into a long. Okay. Okay, I'll explain. We had int a equals 75, and suppose someone says, oh, let me take a long b equals, let me cast into long a. This is wrong, and this is going to be error, because what's the type for a? Int. It can be converted to boxing conversion. It can be done to integer only, right? And integer is not of type long. Long and integer, they don't have this super type subtype relationship. Long is not a superclass for integer. The primitive hierarchy which we are getting, right? We understand what's the primitive hierarchy. Double is the super type, next is float, below that is a long, below that would be int, and below int we have the char and the short, below short there is a byte. Okay, this hierarchy is not there for the corresponding wrapper type. We don't have double as a super class. Double is a class, but it's not a super class. Okay, we have the two classes, not a super class this way. Okay, fine. If you want to know the hierarchy, here there is some hierarchy. Okay, we have the hierarchy like this. We have a class called number. Okay, and under number we have double. Subclass of number is double. Subclass of number is float. All of them are number, that's it, but they are not super type subtype among themselves. Double, float, long, integer. Okay, and okay, there's another thing which is not proper here. Okay, these are some things which may not be exactly which have probably, there are some loose things in Java also here. Okay, fine. So we have the double, float, long, integer, and short, and the byte, but not the character. Character is not here. Okay, character is a separate class. Boolean, anyway, Boolean was never a number in Java. Okay, so Boolean and character, they have been, so character somehow has got left out from the number type.
So a second, I'm sorry. No, character that you just wrote is wrapper class, right?
Yes, wrapper for the corresponding char.
Yeah, but cats are represented as ints, aren't they?
Yes,
As
char are
yeah,
numeric type.
yeah, the CH here, small cat.
Yes,
Big. Uh,
this
Please
is not.
repeat what you said. Is a character got left out of number class, but every character is represented as an hexa, has a number.
Yeah, it has a number. That's not a problem.
Yeah.
What I'm talking about is a class. There is a class in Java called number. Okay.
Okay.
And these wrapper classes. We know these are all classes, right? So these wrapper classes are the subclasses of the number class, whereas character has not been put as a subclass of the number class.
Okay.
Okay, fine. Clear. So yeah, so some mismatches here and there. Anyway. Fine. So these classes here, they are all known as the wrapper classes. Okay, that is double float, long integer, short, byte, character, and boolean. Okay, fine. So this was about boxing, unboxing, conversion. Yeah. So coming back to the arithmetic operators. Fine. Now, only thing of what I would like to highlight is the difference here from C language. Fine. In C language, fine. Okay, I think this modulus is available only for integral types. You can't do it with the floating point type, right? Okay. In Java, modulus is available for uh, referenced for floating point type also. Okay, fine. So fine. So you could even do with floating point types also. You can take a modulus. Okay, for example, someone says double. Okay, A equals 2.5, 2.7, and so this double B equals 0.3 or 0.4, let's say. Yeah. And double C equals A percentage B. Yeah, what will be C? Remainder on dividing.
3.
It would be 0.3.
2. Oh my God, my brain has stopped working. Okay. So मैं सुबह बहुत जल्दी से जागी. Sorry. अभी कितना मिनट टाइम है क्लास में?
Around 40 minutes. Want to have a small break?
Even if you give, if I'm liking the class, I want to take a break, but I've been away from 4 o'clock. The break won't help. Please continue. Not for me, at least.
Okay. Fine. See, it will become 0.3. That's fine because 2.7, 0.4 into 6. 0.4 into 6, right? 0.4
So
into
not
6.
0.3, so decimal disappears. 2.7 by 0.4 is same as 27 by 4.
That's what
The
here.
remainder is 3.
Now
Not 0.
here what will happen is like this. 0.4 multiplied by 6 would become 2.4.
Okay.
Right? And therefore what remains is 0.3.
Okay. I'm wrong there. Okay, thank you.
Fine. So the idea here is in Java you do have floating point type also. Fine. This modulus works even for floating point types. Okay. And so arithmetic operators, I think we understand all of them as such, right? In C language, we know this. Okay. So one is arithmetic operators. Another is the next thing here. Let me take this. Is a string concatenation. So we have a string concatenation which uses the same symbol as addition. So it is plus. Okay. So we have string concatenation. I am putting it as a same thing, same symbol is overloaded. It's used for multiple purpose. Okay. So plus available for numeric addition, plus also available for string concatenation. Okay. Let's understand string concatenation. Okay. In Java, okay, any data type, string is a special type, understand this, can be converted to a string. Okay, so everything can be converted into a string. That's one thing you should understand. Okay, so fine. So we call this as a string conversion, right? So you can convert anything into a string. Okay, and how string conversion can be done? Oh, it's done with the help of this operator itself. Let's check this. Okay, so every data type is convertible to a string. Okay, now to explain the string concatenation, okay, fine. So how string concatenation? If any of the two operands of plus, okay, find plus as a binary operator, so it has two operands, right? And for example, if I say a plus b, okay, fine, in this expression, if either of a or b is of type string, okay, if either a or b is a string, fine, then plus is string concat is a string concat is used for string concatenation. Okay, fine. Okay, is used for string concatenation. So either of them is a string, right? Right? How it will be done? First, it will be the other type. The other type means here what I mean is the if it is a non-string, okay. Okay, the one of the two which is not a string, okay. If it find the other type will be converted to a string, and then the string concatenation happens. Okay, I'll give with an example what I mean here, right? So we have what 5 plus 5 plus is 10. Okay, so this is one expression which I have written, and I'll put another expression. Okay, so we have to see the result of the two expressions. The other expression says 55 is plus, okay, so it says plus 5 plus 5. Okay, so there are two expressions like this. Okay, now how this one is evaluated? Let's evaluate this. Okay, so we evaluate this. Okay, how does this get evaluated? Is like this. First, it is looking at 5 plus 5. Okay, so this would be arithmetic operation. 5 plus 5, oh, that's an arithmetic. So it becomes 10 plus is 10. Okay, and then, oh, that 10 needs to be converted to a string. Okay, and then it would become, fine, this is how it has been evaluated. Okay, let's evaluate this one. Okay, so what would it be doing? Yeah, so first it would do, so this one, if I look at this, fine, the first step would be, oh, and fine, it looks at this particular plus operation. Okay, so what is it? One side is a string, other side is a non-string. So convert this into a string. Okay, fine. So conversion, right? Conversion to a string, because one is not a string. Then that's a string concatenation. Okay, then convert to a string. Okay, and then the string concatenation. Here how they get evaluated. Fine. If the other side is not a string, it needs to be converted to a string, and then the string concatenation. Here, okay, so plus as a string concatenation. Fine. If I want to convert anything into a string, what can be done? Suppose I have some, yeah, if I have something like x is some expression. Okay, could be any type, right? We'll just say x plus, that's it. Yeah. So what we have done, we have given a string with the size of 0. But it's a string. So because it's a string, this x will have to be converted into a string. We are not looking at currently how string conversion happens, or okay, I'll show that also here. Okay, fine. String conversion for numeric type should be okay, or even for the Boolean type should be okay. Fine. True converted to a string would become true as a string, right? True, false, fine, for Boolean types. For numeric types, yes, we understand a string conversion happens. Okay, fine. Now it is for the reference type that we are looking at string conversion. So string conversion for reference type. Okay, how string conversion for reference type happens? So if I have a variable, right? Okay, reference type would be, if I have a variable x, I have not specified the type. Okay, some reference type. Okay, when there is some reference type and we have x. Okay, one of the things which is possible for x is it will this x will refer to some object, and we understand if it's a reference type, they are reference to object. Or the other thing which is possible is I'm saying it's not referring to anything by using null. Okay, either it is this or it is some other object. And this is how it would be. Okay, right? Okay, so now if someone says x plus this, yeah, okay, what would happen if x is null? Okay, and if x is null, then it is. So if x is null, this is what would happen. Okay. If x is some object, then okay, it will be saying x dot toString. We have a special method called toString, which we can use on anything which is a reference type for string conversion. Okay, fine. If x is any kind of a any object, right, which is not, it is not mentioned as a null. If x is not a null, then it will be using x dot toString. If it is null, then the string conversion would be null. Right? Want to check this out on JShell? Okay. Fine. We can check with JShell. Okay.
Yes, yes.
Okay. So if we had something like okay, so we what type we can use? Maybe we would like to use the type called
Oh, this is the problem.
okay. I'm just creating an object. There is a class called date. I've used it. Okay, so it's not a string type anyway. So fine. If I say d dot toString, right, that's what the output is. And if I say d plus, it's a string conversion. Okay. Okay. Now if I say d equals null, I can say d plus double quotes. It's giving me the string null. And if I say d dot toString, yeah, what should be what should happen if I say d dot toString? D is null.
I don't know what is null, but
Null means it's not referring to any object.
any object. So what
It's
is
a,
toString?
so what happens if someone says d dot? We understand that if there is a reference type, I should be using the toString to convert it into a string, right? But if there is no object there, and if you are saying, oh, let me do let me convert it into a string by using the toString method, okay, this is what would happen. It will be an error, null pointer exception. Okay, it's going to be a null pointer exception. Okay, so the easiest way to convert into a string would be for anything.
If it is not a null, then use toString.
No, whether null or not null, I'm not bothered about null or not null. I can always say plus and a simple string, right? This is string conversion.
तो ये हम पाइथन में भी करते हैं.
Okay, yeah, okay, right. So string conversion, just to a plus and empty string, zero length string. Okay, so that would be your string conversion to take care of even the so that you don't get an error even if it is null. Okay, so you'll get, oh, this is null, basically you'll come to know about it, but not through an error. Okay. Fine. I think I'll paste it here. This one, you want me to copy all this? Oops. Okay. I'll just copy this. I'll paste it here. Okay. Okay, fine. So clear about the string concatenation, right? Okay, let's continue with the next category of operators. Okay. So next category. So arithmetic we have finished. String concatenation, which again uses the plus character. What's the next one?
Comparison, logical?
Comparison. Okay.
Yeah. Or logical, I guess.
Yeah. Then we'll go to that. Okay, one by one. So
Okay.
comparison is
Less than, greater than, equal to.
okay, less than, greater than,
Equal to,
less than equal to,
greater
than equal to, then equal to,
double equal.
and sorry, not equal to. Okay, fine. These are the comparison operators.
The other day you were talking about it.
Which one?
There are 3 equal to signs somewhere, right?
No, no, we don't have in Java. Java was doesn't have this. Okay.
Doesn't have it. Okay.
I think Ishan was just pointing out that okay, .NET has something.
But in Python you use C sharp you
C sharp has that. Yeah.
Yeah.
Okay. Anyway, so we have these comparison operators. Fine. Now here, the comparison, the first 4 of them are available only for numeric types. Okay, and we understand how they would work. Okay, there are a few special cases for the comparison of numeric type. There are few special values. Okay, and we understand that for the floating point types. Okay, first 4 are available only for numeric types. So you can't have less than and greater than things for Boolean or a reference type.
Okay. Or for characters you can, right?
Yeah, character you can. Yes, you can. You can. Okay. You can. Okay. Fine. Okay. Now, talking about the okay, the first 4 types. Yeah. Okay. So numeric type. Okay. Few special cases. Okay. Fine. Comparison. I'm just showing the comparison. There are special values in floating point type. Fine. Which are those? Infinity. Right. We have the infinity. The negative infinity. And of course NaN, not a number. Okay, fine. These are the special values, and for these special values, if you make any comparison, yeah, what would happen? Let's check this. Okay, So infinity is always considered greater than any other thing. Minus infinity, when used in comparison, is less than all other values. Okay, when that anyway is natural, right? What about something like this? If I have got float or maybe even double, okay, d equals, and we know from where we can pick that value. Okay, suppose we have done this, right? So we get double has the value which is a not a number. D is not a number. Now what do you think is D double equals D? True or false?
My God.
It's
Not a
not a
number
number.
equals.
It's not a number.
So how can you use double equal to? It's false.
This is false. See, something where you're saying double equal to the same value and you're saying, oh, it's false. Clear? So NaN is a special value where all comparison will return false except for, okay,
Not equal.
that's the only thing where it will say, yes, that's correct. Okay, fine. D is not equal to D. It's not a number. Okay, but all other comparison, less than, greater than, anything, any comparison operation for not a number value, that will result in false. Okay, so that's a special case I wanted to just point out for comparison within the numeric. Otherwise, we understand how the numeric comparison is done. Okay, now coming to the part which is the last two operations, right? Double equal to and the not equal to for reference times. Okay, fine. So I'll take a small example like this. We can create some object maybe. Yeah, we may. Which object would you like to create? Okay, let's say we have a class called date. Okay, and there's something called local date and equals. Okay, dot off, and what's the today's date? I'll just say now. Okay, so today's date will be picked up. Okay, so D1 will have the today's date. Okay, I think I'll take this session on the J shell again. Okay, let's go to J shell. Okay, fine. I'll need one import. I'm just using something which I've not talked about earlier. Java.time. Let's now do this. Okay, so this should work. Fine. So we have created one object of type local date. Okay, let's create another object of type local date. Okay, because it is off, we'll have to just check this. I'll have to check this. What do you think should be the answer, true or false?
True.
It's false. Both the dates are same. They have the same values. In value terms, the content of the two objects is the same. Okay?
But the address referred to is different.
Yeah. Okay. But one thing here, what we have is, just like we could do a two-string first string conversion. For comparing reference types, we use equals. This will be a Boolean expression. Okay, instead of using double equal to, use this one. Use equals. For reference types, fine, if you want to know equality, use equals method. Okay, and now explain what is actually happening here. See, we have got D1 initially, okay, and we said, so D1 is a reference. It refers to a local date object, right? And that local date object has the value for day, month, and year. Okay, it has specific values which are for what's today's date is 30. Okay, then it says yes, the month is June, and the year is 2023. Right? Okay, so that's what D1 is. And then we have created a D2 as a separate object. Okay, and we are saying, okay, D2 has, again, it has the same content. Okay, 6 and 2023. D2 refers here. This is what is the case. Okay, the content is the same. So are the two dates equal? Then answer is yes. The two dates are equal. Are the two dates same? Fine. When we use D1 double equals D2, okay, we are talking about whether D1 and D2 is the same object. Okay, so fine. So this means whether D1 and D2 is the same object. So is D1 and D2 the same object? No, they are two separate objects. Their contents are same. And they are equivalent dates. The two dates are equal. But the two dates are not the same object. If someone had done D2 equals D1, okay, if someone does like this, then what would happen? Oh, you stop referring here, make D2 refer to this. Now if someone says D1 double equals D2, that's true. Yes, they are the same object. Are they same object? Yes, they are the same object because they both refer to the same object. So double equal to whether it is same or not. Okay, it is to check whether it is the same object. Fine. It's not about checking equality. If you want to know whether D1 and D2 are equal, and we will use equals D2.
But single equal is the same as equal.
Single equal is assignment. Make it refer to that object. Single equal is the assignment. For reference type,
D1
yeah.
Okay. For reference type equals
is for equality. Yes.
Okay. But double equals check only the box containing the value.
Whether it doesn't check the content, it will check whether it's the same object or not.
So directly we cannot compare a reference variable, right?
We should use equals for equality.
Yeah. For that we need to use equals D1 dot equals D2
Yes.
set. But directly we cannot compare a reference variable.
No. Compare means in which manner? Oh, you want to the other
comparison. Yeah, D1 equal D2 like that.
This is also not valid. Okay, any comparison operator is other than the last two I said. Okay, so you may use D1 double equals D2 to check. So you can use this, but then it is only saying whether they both refer to the same object. You can have multiple references variables referring to the same object, right? Okay, so this is just to check whether it is referring to the same object.
Yeah.
Okay, fine. See, for example, if you look at that earlier case also, right? So when we did something like a2 equals a0, okay, fine. Here, someone could have checked this and said, okay, is a of, sorry, here it is a of 2 or a of 0 double equals a of 2. Yes, then it would say true. After this assignment is done, this would be true.
Correct.
Okay, otherwise it was false. Though they all had zeros, everyone, all the arrays, all the rows contained zeros initially, right? Okay, so the content is not, double equal to is not about the content of the object. Okay, it's only saying, oh, if they're both the same object or not, that's it. Yeah, so equality is one thing and it being same is another thing. Same object is also another aspect. Fine, clear?
Yeah.
Okay, so reference, this is how the references would work. Okay. Okay. Fine. Okay, I think I'll just copy that additional part from the J shell. Okay. Okay, fine. So fine. So clear on the comparison operations, right? Fine. So the comparison
Yes.
operators, that should be fine. Okay, all of these. Okay, fine. Because last two are not available for all types. Whether these are the earlier ones, these are not for anything other than the numeric types. Okay, fine. I think we can continue tomorrow now. I think so. Tomorrow we'll continue with the operators. Okay, and we'll be looking at
So tomorrow.
not tomorrow. Sorry, on
is
Monday. So yeah.
Monday. Yeah.
So yeah, yeah, it's a weekend. So fine. So we'll continue on Monday. Okay. So that time we'll look at start with the logical operators, the assignment, and the other things, other aspects. There are so many other operators. Okay. And once we finished with the operators, okay. So fine. So after operators, so this is, let me put this is next. Okay. So next should be on operators and so remaining operators and the statements. Okay, what are the statements like if, else, and all those various many of those you will be knowing already, fine, but where required I'll just point out the things. Okay.
Okay.
Okay, fine. So have a nice weekend, everyone.